Hi, 8th grade, Mr. Pastel here. Today I'm going to guide you through Lesson 2.6, reviewing key ideas about natural selection. And before I start, can I say if people aren't watching these videos, I'm not going to make them. I want to be helpful and guide you through these things, but if you guys don't watch them, then what's the point of me making them? This lesson is divided into 3 groups, which were determined last Friday with your critical juncture assessment. So the groups are green, purple, and blue. I'm going to go in that order. So you can click in the description below to jump to your color. So I'm going to start with green, then I'm going to do purple, then finally I'm going to do blue. So if you're in the green group, you start off by looking at a histogram. Which neck length traits are present in this population of australopes? So in the histogram, we see neck length of 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't see anything in 10, so that should help you there. Answer the following questions about this australope population. Some australopes have short necks. Yes, some do. Long necks. Yeah, not 10, but long. Most australopes have medium length necks. I would agree with that. There are no australopes with very long necks, level 10. I agree with that. All australopes have the same length necks. No, because there's a distribution. You see that there's 9 different neck lengths there. Let's move forward to part 2. Okay, we're going to make a prediction, I think, before we launch into the sim. Consider a population of australopes where all the thorn palms are tall. The australopes have this distribution. So they're kind of like giraffes, so longer necks make it easier for australopes to eat taller thorn palms. In the starting population, what is most common? Short, or medium long? Let's see, I would say the peaks are around 3, 4, and 5, so. Which traits for neck length do you predict will be most helpful for survival? So, tall thorn palms are level 8. So what do you think is going to be best for survival? And which traits for neck length do you predict will become most common over time? Well, the ones that become most common over time will be the ones that are good in the tall thorn palm environment because of adaptation. And then you're going to test this in the sim. So open australope neck length mode. Run and observe the results over 25 generations. Analyze and compare starting and ending histograms. Answer the questions below. So in this first one, did this load yet? Come on. Did any traits disappear from the population? It's taking forever. Okay. It was australope neck length, I believe. Yeah. They don't say to make any changes, so I'm just going to run it. Then, for the second test, I'm going to increase the thorn palm height to level 10. And probably what's going to happen here is if you don't start with australopes with level 10, they won't be able to reach the leaves. So I'm guessing they're going to die if it's set up that way. And let's jump to part 3. So in part 3, there's a sorting tool. And what you're going to do is read the Australope cards, sort the cards. First, sort them by armor level. Then sort them by number of offspring. Then sort them by lifespan. Actually, it sets that up for you. Then take a screenshot. And which armor trait is adaptive and which will become more common over many generations? Which armor trait is adaptive? Select any of the responses below that help explain how the trait will become more common. So this is testing how well you understand natural selection. How do traits become more common? It's usually not because of need. Parents with any traits will have offspring with this trait because they need to. No. In natural selection, what matters is survival and reproduction. So this one goes with survival, but even if you just survive but don't reproduce, then it's a failure. So it's going to be reproduction. Which pattern did you notice when sorting the cards? Why does this pattern exist? And after many generations, which trait will become most common? Okay, I'm going to go to the blue group now. So the purple group, excuse me. Purple group. You will investigate a population of Australopes with variation for armor. There are Carnothons in the environment, and Carnothons are more likely to eat Australopes with less armor, so it's a defensive adaptation. Observe the histogram and images of the Australopes below. Oh, so this one has a tiny bit of armor here. Make predictions about what will happen to Australopes in an environment with Carnothons. Okay. So if it has almost no armor... Oh, the back spikes. If it has almost no armor, what do you think is going to happen? Yeah, it's non-adaptive because it's going to get killed very quickly because it has no defense. Which Australope picture do you think will have more offspring? Probably the one that will actually survive. So I would say this guy. Let's move to part 2. Which traits... Oh, I gotta go to purple group. Okay. Australope armor. Sort the Australope cards with your partner. So you're going to sort the cards by weakest armor. But you're going to sort the cards by armor. You're going to sort the cards by offspring. And you're going to sort the cards by lifespan. These 5 cards. Screenshot that. Which armor trait is adaptive and will become more common over many generations? Well, let's see. Armor's going to be adaptive if it produces a lot of generations. Anything is adaptive if it's going to be a lot of generations. Now, which of these is true if you understand natural selection? Natural selection is not just about living a long time and not reproducing. Natural selection is not about having a trait because you want it. Natural selection, you definitely can't change a trait during your lifetime. It's really about surviving, but more importantly, reproducing. So you pass on your genes. Which pattern did you notice when sorting the cards by armor level, number of offspring, and then by lifespan? Maybe you see some sort of commonality there. Why does this pattern exist? And after many generations, which trait will become the most common? Which armor trait? And let's move to your last part. Purple group. You're going to be reading about otters. Quickly annotate the article. Oh, the bottleneck effect is about when a small part of a population survives, and basically only their genes will form the future generations. A very small amount of the population. What traits do otters have that is adaptive to their environment? You guys can find that in your reading. How did the otter's environment change between 1741 and 1911? So let's look for those keywords. Okay, 1700s to 1911. Oh no, humans killed nearly all the otters, so that's probably what caused the bottleneck. Do you think the population will ever return to its former distribution? Let's see the end here. If the species recovers and the population grows, the population will still have much less variation than it had before the bottleneck, because you got rid of that variation when you had that bottleneck, because of humans killing all the otters, basically. All right, let's go to the last group here, blue. Blue group, congratulations. You guys did the best on the critical juncture assessment. Good job. So you really understand natural selection. List some examples of environmental conditions that could determine which traits are adaptive. So what this means is, what are some conditions of the environment? What are some things in the environment that could cause traits to become adaptive? So besides temperature, what other parts of an environment could change the organisms? That's a tricky question. But you could use some that you saw in the simulation. Temperature, maybe amount of rainfall is important, because that can determine like the adaptive traits of a plant, for example. And there's lots more. So which statement below describes how environmental conditions affect survival and reproduction? Environmental conditions make all individuals equally likely to survive. No. Because some individuals are more likely to survive than others. So the second one looks pretty good. Environmental conditions do not have any effect on survival. No. I need more information. It does depend on conditions, but I like the second answer. I don't know about you. Explain why you chose the answer you did to the question above. So are you going to choose the second one or the fourth one? Let's move forward. Blue group. So you guys are going to read about otters and the bottleneck effect. The bottleneck effect is basically when you have an original population and then there's some kind of event that causes only a fraction of the original population to survive. And in this case, humans cause that bottleneck effect, because humans killed nearly all of the sea otters, sadly. But what traits do otters have that is adaptive to their environment? I think it mentions it up here. So otter skin is adapted to cold water. How did the otter's environment change? Well, humans. Kind of like the predator there, right? Why did this change cause a bottleneck? Well, because humans, hunters, reduce the population by so much. Do you think the population will be able to restore its former distribution? Well, whenever you have a bottleneck effect, that's hard to do. And it says down here, if the species ever recovers, the population will still have much less variation than it had before the bottleneck, because it just doesn't have the same gene pool that it used to have. And let's move forward to your last part, guys. Blue group. So you guys are going to do the color change mission. Let's take a look. So you're trying to reduce the variation of the Australope population. You're trying to bottleneck. That's cool. In fewer than 30 generations, change the starting Australope population into a population of at least 70 individuals with low variation in color traits. So your histogram should not have more than 4 traits. Do this without adding a predator. Try out your strategy. So I'm interested in the solutions that you guys are going to come up with to do a bottleneck with low variation of color. You guys are the smartest group, really. So the group that did the best on the critical juncture. So I'm not going to give you too many hints here. Tips. You can modify the abiotic factors. So what abiotic factors could affect color? Do not make any changes to the starting Australope population settings. So change the abiotic factors and see what you can do. Return to build and press rebuild. So show me your histogram. Show me that bottleneck. And you should only have 4 or fewer versions of the color traits. And did your strategy work?